All right, let's get started with some ideas about how to teach fractions or tips, ideas, strategies. And I'm going to start really basic and kind of build up as we go along. Think of these as recommendations. So first of all, equal sharing, right? So we could initially have students solve problems that involve two or more people sharing a set of objects. The problems could then include sets of objects that could be evenly divided. There's our fruit. So there's no remaining object and there's no need for further partitioning into fractional pieces. Or we could introduce further partitioning into fractional pieces. All right, there's a start. Now here's an example where we have individuals, where we have a set of individuals and we need to divide the number of cookies, 12 cookies, across 3 individuals. And there's our division, gets into our fraction element, and we solve our problem from there. Now, let's take this cookie idea and extend it a little bit. So here we can pose problems where they're sharing, and with the sharing, students are dividing one or more objects into equal parts. Now the focus of these problems shifts from asking students how much things are each person should get to asking students how much of an object each person should get. For example, let's take our cookie there, and we have one cookie shared between 4 students. Now we could extend that from 4 students to, let's say, 8 students. Now, this idea of sharing could involve one object, right? That involves, breaking into units, 1/3, 1/4, 1/9. And then we could start beginning understanding with that in terms of the scenarios of multiple people with objects. Okay. And then we go from a unit, differences between or distinction between a unit and a non-unit fraction. And because of that, we help the individual reduce it into lowest terms. The non-unit fractions are composed of unit fractions. For example, 3/4 is equal to 1/4, 1/4, 1/4, but the opposite is not the case, and share the same situations, etc., etc. Okay, now we can also get into this idea of sharing activities where they understand the relative size of the fraction. Good. So here we introduced ideas like a candy bar, and here we could have an individual where we have a candy bar, and students can compare the size of the pieces of that candy bar when we're sharing it equally among 3 people, 4 people, 5 people, 6 people. And then we can encourage students to notice that as the numbers of the people sharing the object increases, the size of each person's share decreases. They should then think, of course, of this idea to formal fraction names and encourage the students to compare the fraction pieces using fraction names. So 1/3 of an object is greater than 1/4 of an object, etc., or 1/3 to 1/4. So, all right, so that's an element in terms of with pieces in terms of elements. Now here we can partition the objects into larger or smaller pieces. And here, for example, we could start partitioning, elements of like pizza. For example, solve the problem of 8 children sharing 4 pizzas. Students might partition all 4 pizzas into 8ths and then give each child 4 pieces of the size, 1/8, right? Alternatively, students could divide each pizza into 4ths and give each student or each person 2/4, or divide each pizza into halves and distribute 1/2 for each child. Students should then understand, of course, that there's different ways to partition the pizza. Each partition method results into equivalent shares, and we go on and on and on. All right, let's stay with the pizza idea. And here is to understand that equivalence in terms of the partitioning of numbers. Here, for example, we can compare the new solution of 2/4 to the original solution of 4/8, showing that 2 amounts are equivalent. And to drive home that point, 8 children could then sit at 4 tables, and having 2 children at each table sharing a single pizza and reaching the same or more familiar concept of 1/2. All right, simple things, but at the same time, incremental, and at the same time, supportive and developmental for the individual. So next, of course, building on students, that informal understanding, developing more advanced understanding of proportional reasoning concepts, right? Begin with activities that involve similar proportions, and then progress to activities that involve ordering different proportions. Let me give you an example. So for example, here we can offer a class to discuss the number of students it would take to balance, yeah, I know it's old school, but a seesaw. 1 or 2 or 3 adults on one end, etc. Or for example, taking a liquid mixture, for example, lemonade mix or food coloring, and facilitate discussions comparing the strength or the concentration of different mixtures. Oh, okay, so we're starting to quantify things there. Or for example, we could discuss problems that involve one quantity increasing as another quantity increases. Here it could be, height and clothing, or foot size or foot length and shoe size, offering that type of visual chart and noticing in terms of the proportional correlation there. We could also, in terms of patterns, simply show repeated patterns. And that's the idea of concept of a ratio. For example, students could complete a pattern such as, and this isn't the exact pattern, okay, but the idea of, let's think of a blue star, red square, blue star, red square, blue star, red square, and so on, etc. Or as you see here, in terms of we have a blue square, orange triangle, circle, red circle, blue square, orange triangle, what's the circle, okay? We discussed how many blue stars there are for every red square. In my example, students arrange the stars and squares to show what they get repeated and have students change the pattern to a different ratio. For example, 3 blue stars to 1 red square, etc. So here we have, 2 blue circles to every green diamond, etc. So these are patterns, and if patterns get into ratios, and ratios get into fractions. Now we can also use the measurement in terms of number lines and things of that nature to show properties. And so let's take into consideration this idea that we want to provide opportunities for students to locate and compare fractions on a number line. All right, great. So here we go. One way to build or introduce the idea of locating fractions, emphasize that fractions are numbers with quantities. We talked about that in an earlier presentation. And to illustrate, let's locate 3/5 on a 0 to 5 number line. And here the teacher might first mark and label the location of 1, and then divide the spaces between each whole number into 5 equal parts. After this, the teacher might add the labels, right? 0 over 5, 1/5, 2/5, 3/5, 4/5, and 5/5. And then they see the connection there in terms of where 3/5 is located, highlighting that, displaying it there within the element of a whole fraction, a whole number, as in the fraction 5 or 5/5. Again, making the connection between the fraction and the whole number and where it sits, all very relevant. Now here we can take the number lines and, for example, now we can locate 2/5 and 4/10 as a single number. And so here we have that visualization of, okay, so they're different fractions, but in terms of their alignment to different fractions, but potentially meaning the same number. So for example, 5/10, 4/8, 3/6, 2/4, 1/2. This allows the teacher to show there's an equivalent aspect, right? And allow individuals to show where they are in terms of the number lines, of course, and then they can use a ruler to identify the equivalent fractions on the stacked number line, as we're showing here, and et cetera, et cetera, et cetera. All right, then we can extend this just a bit to help students understand that fractions can be represented as common fractions or decimals or percentages. So here we go from different fractions to here we go from, okay, fractions to now potentially how they see itself on a line like this, to percentages, to decimals, etc. All right, so simple stuff, but it advances. Now here, of course, we use the area models, right? Number lines and other visual representations to improve the student's understanding of that formal computational procedure, right? And by doing so, we help students understand why procedures for computations with fractions make sense. All right, I'm rushing through elements of this, but very simple ideas, and these simple ideas make connections to something more complex. First of all, very introductory, but then you can build upon the same idea, same method, to be able to offer them more complexity. Now, Khan Academy and some of the videos do this. IXL and some of their illustrations do this. And there's a list of different tools that do this, but identifying that the tool is doing that, identifying the lesson is doing that, that's a critical aspect, and matching it between these examples. Now, the last aspect, just to kind of reinforce, is the fact that, the reinforcement of the fact that students make common mistakes, and we've talked about this before, and understanding here, for example, with denominators. So, for example, teachers can demonstrate that when adding, pieces corresponding to fractions of objects, so for example, 1/2 of a circle and 1/3 of a circle, converting both the elements so that we see the common denominator. All right, so for example, here in terms of to 6s, right? Both fractions allow them to be added, right? And discuss when students will multiply denominators, always indicate a common denominator that can be used to express both original fractions. Simple stuff, I agree, but at the same time, they're allowed to kind of see that visually. They're allowed to kind of make that connection, and it's very relevant as a simple strategy tip for them to be able to apply and integrate into what we're trying to do instructionally. Okay, I'm going to take a break here for a moment, have us kind of reflect a little bit, think about some of the activities that we've offered, as well as some of the resources we've offered to allow us to do some of these things. And then we'll move on to the next part of the overview of fraction strategies, tips, and ideas of better incorporating that instruction into our struggling learners.